Hello, my beautiful, amazing geometry students. I am so excited because our PVL is finally here. And this is our first lesson. Our PVL is all about area and surface area and volume. You have either done your entry event or you will be doing it next class. And we're going to get into reviewing some area and maybe doing some area that might be new to you. So here we are, lesson 5.1. We're going to find area of triangles, rectangles, parallelograms, trapezoids, circles. We're also going to find area of composite shapes. And we know from transformations that composite means two or more. This should be a photocopy that you have. You're going to take notes on your copy. You can glue this into your notebook and keep it safe with the rest of your notes. So we have our area formulas that we're going to be using. The first one is area of a triangle. Area of a triangle is 1/2 base times height. We have area of a rectangle here. And also perimeter formulas in there, but we're just going to be working with area, so length times width. Area of a square, the side is the same, so that's side squared. Parallelogram, same as rectangle formula, but we call it base times height. We have a trapezoid, it has two different bases, and our circle formula. So we're going to get into using all of those. We'll see them in action. Starting with number 1, we have area of a, and this is a square. So what am I going to do? I'm going to identify my S. This is my S value right here, and I know that area is side squared. So I'm going to take 8.5 times 8.5. Or 8.5 squared. So 8.5 squared. And that is equal to 72.25. And we want to put our units here because it is area is going to be our unit of the length, which was feet, but then it's going to be feet squared. All right, I am doing all of the odds, and I'm leaving the evens for you to do as your own practice. So just so you know, we'll be going through and doing just the odds. So I'm to number 3. Number 3, this is a parallelogram. I see my parallelogram formula right here. Simple one, area equals base times height. So I'm going to use that formula, area equals base times height. So my base is one of my sides of the parallelogram. That's my base, and then my height is going to always be perpendicular to that, 7.1. So I'm going to take 12.9 times 7.1, and I get 91.59 here. It is inches, and we're going to have that squared. All right, on to number 5. This is our trapezoid, number 5. So our trapezoid formula is right here. We do have two bases, so we have a little bit more to do on the previous one. So its area is equal to 1/2 times height, and then I'm going to add my two bases together, base 1 and base 2. So I'm going to take 1/2 times my height is 16 right here. Then I'm going to add my two bases. This could be my base 1. This is my base 2. So I'm going to add 19 plus 27. So when I work that all out, you know, it's kind of nice if I have my TI-84 calculator handy. It does multiple functions for me. I can actually type it all right in there right now. So I'm going to do 1/2 times 16. I'm going to put my parentheses. I have 19 plus 27. Ooh, one shot for me there, and that comes out to 368. So I have 368 centimeters squared. I really want to get in the habit of putting the units on all of these. That's going to be very important for our PBL, making sure we understand the units in area versus volume. All right, number 7. Number 7 is a triangle. So because this triangle is obtuse, we have the height listed out right here. That is my height. The height will always be perpendicular. You know, I want to go straight up and down vertically. And then this will be my base here. The base is always what the height is perpendicular to. So since it's perpendicular to that side on the bottom, that will be my base. I'm going to use my formula 1/2 base times height, and that's 1/2 29.5 times 14. Put that all in my calculator, and I get 206.5, and that should be inches squared. Inches squared there. All right, so on to number 9. We actually have a semicircle over here, so I am going to use my circle formula, but it is half of a circle, and so I'm going to simply take this area formula, but I'm going to add in my 1/2 or divide by 2 at the end. Either one will work. Make sure when we're using our area formulas here, circumference or area, that we're going to use radius. We do have radius listed right here, so not a problem, but some of our questions will give diameter, and radius is half of the diameter. So this is radius here. I'm going to add in my 1/2 because I only want half of this circle, and I'm going to take pi r squared. So that's 1/2 times pi times 17 squared. And I'm going to show us in the TI-84 calculator how we can get that pi button. Just give me a moment. There we go. All right, so here's my calculator here, and I'm going to, pi is actually above the caret. It is in blue, so I do have to push second, my blue button, to access it. So I'm going to do 1/2 times pi, so second caret brings up my pi, times 17, and then I do have my squared button, x squared right here. This raises it to the second power for me, and I get 453.96. That is going to be feet squared. All right, number 11. We have a triangle here, and actually we are missing something for our triangle formula. I see that triangles, I need 1/2 and then base and height, and what I actually have here is I have the base here, but I don't have the height. Now the tool that we have to be able, to be able to solve for the height is, we've just been working with it, and it is Pythagorean theorem. So I don't just use anything on the shape, make sure I'm using the right parts. And so I'm actually going to solve for the height first. This would be my C over here using Pythagorean theorem. So I'm going to do that first. So I got 7 squared, that could be my A, plus, I'll even just call it h squared, equals 18.2 squared. All right, when I work that out, 18.2 squared, what do I get there? 18.2 squared. I get 331.24. Okay, so that's equal to 49 plus h squared. So I'm going to subtract 49. And I'm going to end up with 282.24. and I'm going to make sure I square root at the end. And that gives me h is equal to 16.8. All right, now I'm ready to use my area formula. I'm going to do area as 1/2 base times height. So I'm going to take 16.8, and then now that's my height, and then I know my base is 7. So I'm going to multiply that all together, and I will get 58.8, and that is going to be feet squared. So sometimes a little bit to solve for depending on the problem. All right, we're going to switch it up to some new types of problems. So this says use the area formulas to find each measure. So I'm actually given the area already, and I'm going to be given like one of the measurements that I need, and then I'll always be left with one unknown. So let's look at number 13. It is a triangle. So I'm still going to be looking at my formulas. I want my triangle formula there. And I'm going to write out my formula as an equation. I'm going to substitute in all the values that I know. So I know the area, which is right here. It is 45.5 centimeters squared. I'm going to drop the units in my equation. I don't need them until the end. So that's my area. You know, I'm looking over here. Area equals 1/2 base times height. So I have my area equals, I have my 1/2, and then base, they're telling me, is 14 centimeters. And then I don't know what the height is. I want to find the height. So what ends up happening here is I have, you know, only one unknown, so I could solve this just like I would any of my equations that we've been working on all year. So I'll take 1/2 times 14 to simplify this right side of the equation, and I get 7h equals 45.5, and then I'm going to divide by 7, and I get h equals 6.5. Now, since I'm at the end, I'm going to stick my units back on. This is not area, it is a length, the height, so I'm just going to keep it as centimeters. All right, we have another one of these, just two more for this section, and this is our trapezoid. All right, we have our trapezoid formula right here. So it has a base measures of 23 kilometers and 29 kilometers, so that could be like my base 1 and my base 2, and then I have my area here. Find the height of the trapezoid. Okay, so my area is 390. I'm going to have 1/2 times the height, so I don't actually know the height. I'm going to leave that as a variable. And then I'm going to take my base 1, 23, and my base 2, 29. All right, so I'm going to go through my steps of solving that. I want to, you know, combine the parentheses here and kind of simplify as much as I can on the right side. So 23 plus 29 is 52. So now I have 390 equals 1/2 times h times 52. All right, I'm going to do my 1/2 times 52, and that gets me 26h. I put that in the front because that's typically how we write it in algebra. And now I know that I am finally going to divide by 26, and I get h equals 15. I want to put my labels back on. This is a length, so it is just kilometers. All right, our last one for this section, number 17. Find the diameter of a circle with an area of 380.13 meters squared. All right, so I need my circle formula here. Actually, for a circle, you know, the only thing we need for area is the radius, so that's why they haven't given us any of the other values. So I'm going to set my area of 380.13 I'm going to set that to pi r squared. Okay, now pi is like a constant. I know it kind of looks like a variable in our equations, but it's actually a number. We know it's 3.14. It's got a lot of decimals after that. So what I can do to isolate r is, treat it like it was a regular number. It's in front of r, so I would and it's being multiplied, so I'm going to actually divide both sides by pi. Now, again, in my calculator, I can use that pi button, so I can go and take 380.13 and I can divide by pi. And then I get that number. So I have 120.999. So I'm going to round that, we'll round it to 121. So I have 121 equal to r squared. And then I take the square root of both sides to get rid of that square on the r, and the square root of 121 is 11. Let me get my label in there. So I have r is equal to 11 meters. All right, so for our practice, we are going to take time to do the evens. If you want to pause this video and try them out now, I am going to move on to our composite areas. All right, so composite figures. A composite figure is a figure that can be separated into regions that are basic plane figures, which are the ones that we were just finding areas of before. To find the area of a composite figure, divide up the regions and find each area. Then find the sum of the areas. We're going to break it apart into those shapes we were already finding the areas of, and then we're going to end up adding them up. All right, so let's get right into it. Number one, we want to identify what are these two different shapes that we have. So we're going to divide up into our regions. I see this is like region 1 and this is like region 2. I have a rectangle and I have a trapezoid, okay? I'm going to use those same formulas I was referring to before. I don't have them up on the screen, but still same formulas. So I'm going to find the area 1. I'm going to call that A1 instead of just saying A and A. That just kind of helps me in math, separate them out. This will be helpful when you're showing your work in your PBL too. So the rectangle is area 1. That's a simple one. I'm going to go length times width. So my length is 12 here and my width is 23. So 12 times 23 and I get 276 and that's going to be centimeters squared. All right, I have my second area, my trapezoid. So my trapezoid formula is 1/2 base 1 plus base 2 times the height. And I actually need to do a little bit of work to find my height. I see that this whole thing is 18 and this part is 12, so if I subtract those, I will get my remaining height here, which is 6. So I'm going to take 1/2. I have my base 1 and my base 2 is 23 here. Oop. Sorry, moving it around a little bit. There we go. So I have 23 down here as well. That's a 3. So 15 plus 23 and then times my height of 6. And when I multiply that all out, I get 114 centimeters squared. I'm going to get my final area by adding those two together. So 276 plus 114, and that is 390 centimeters squared. All right, so 2 composite figures there. On to number 3. I'm seeing three figures here. I have a rectangle, I have a triangle, and I have a semicircle. So we've done all of those before. So I'm going to have area of my first figure, my rectangle. I need my height. And so I'm going to have to do a little bit of solving here. So I see I have 9 right here, and that's going to put 9 over here and also over here. So the whole diameter is going to be 18. So I have 9 there and 9 there. That would also put, you know, if I create another radius like that, I'm having trouble doing my dots, that would also be 9. So I kind of need that to help me out with my rectangle. If I know the whole thing is 26 and I just want this part right here, well, let me take out this 9 that exists right there. So that would put me at 17. So I have 17 for my width or my length, whichever one. So I'm going to take 9 times 17 and I get 153. All right, then the area of my second figure, that is a triangle. If I knew that this was 17, this is also 17. This part right here is 7, which will make the bottom, or the height of that triangle 10. So now my triangle, I have 1/2. The base of it, is 9. And the height of it is 10. So 1/2 9 times 10, which is going to be 45. All right, then I have the area of my third figure. It is a semicircle. So I'm going to take half of my circle area, which is pi r squared, and I see that r is 9. Just going to circle these because that was kind of confusing me, that 3. Remember, that's figure 3, figure 2, and figure 1. All right, and then if I put this all in the calculator, 1/2 times pi times 9 squared, don't forget about the square, that is 127.23. Then I will add them all together. And I get 325.23 feet squared. Add feet for all of them. All right, on to number 5. All right, looking a little complicated here, but nothing that we can't handle. I have 3 figures that I see. I see a square. I'm having some technical issues. I have a square here. I have a trapezoid here. And I have my triangle over here. So my square. Okay, let's see what's going on here. Oh, looks like I have a little right triangle again to solve and actually find the base of my triangle. You know, I have the height, but I don't have the base. So I'm going to do that. So right here, I'm going to use my Pythagorean theorem. Okay, so I'm going to take, okay, this is 12, that puts this 12 over here, and that's my hypotenuse, and then 9.6, so 9.6 squared plus, we'll just call it x squared equals 12 squared. Okay, we've done a lot of Pythagorean theorems, so I'm not going to show each and every step. Once I square my 12 squared and subtract my 9.6 squared, I'll get x squared is equal to 51.84. Then, of course, I take the square root of both sides, and I get x equals 7.2. All right, so that is my base right here, 7.2. And then, this other part is 7.2 as well. So it looks like the side of my square is 14.4. So my first area is going to be 14.4 squared. It's a pretty simple one. And I get 207.36. All right, then for area 2, that is a trapezoid. I know my first base because I had it from my square. I know my second base, like this is base 2, this is base 1, and I need to figure out my height. So I see that overall this whole figure is 25.4. If this is 14.4, then I can subtract to get the rest, and that ends up being 11. So my height of my trapezoid there is 11. Let me put a number there. Oh my goodness. Okay, so I'm going to take 1/2. I'm going to add my two bases. So I had 14.4, the side of the square, plus 10. And then multiply that by my height, which is 11. When I work that all out, and just put it all right into the calculator, I get 134.2. All right, and then I have one final area in this one. And that's my triangle. It's going to be 1/2 my base, which is 14.4, and then times my height, which is 9.6. And let me get that. 1/2 times 14.4 times 9.6, and I got 69.12. All right, and then finally my area, I will add them all together. So I'm going to have 207.36 plus 134.2 plus 69.12. And I got 410.68, and it is meters squared. All right, we have a couple shaded regions problems. I'm only going to do one. You don't have too many. I think you can handle them. So I'm doing number 7. It says to find the area of the shaded region. Oops, I didn't copy this down on my slide, but you can write it down. You're going to find the area of the entire figure, and then you're going to subtract the area of the non-shaded regions. Okay, so we'll do that here. So the entire figure, the larger one, is the rectangle. So that's going to be we'll call that my first region here, and we'll call this one my second region. So the shaded region is what I want. So area of my first region is rectangle. It's going to be 14 times 25, which is 350. Okay, then my region of my second, or the area of my second region is my triangle. It's going to be 1/2 base, which is the length of the rectangle, 25, and then the height is 11, and that comes out to 137.5. Okay, and then to get my area of the shaded region, I'm going to take the larger one, 350. I'm going to subtract 137.5, and I get 212.5 centimeters squared. And that's how we do our shaded region problems. Thanks for sticking with me. I know this was a bit of a lengthy one. Just like in the first section, I want you to do the remaining problems for practice. Most of them are evens, but I did leave a couple of these shaded region problems for you. And we'll talk about them in class. Good luck, everybody.